I'm delighted to introduce Dr. Eleni Bozia, a lecturer in the Department of Classics at the University of Florida, and she's the co-director of the Digital Epigraphy and Archaeology project, which she's going to be talking to us about today. So thank you very much, Eleni.
Thank you very much for inviting me here and for giving me the opportunity to present you the Digital Epigraphy and Archaeology project, which is a collaborative work between the Digital Worlds Institute at the University of Florida and the Department of Classics at the University of Florida. And today I'm speaking on behalf of the whole group, Dr. Angelos Barboutis, Dr. Robert Wagman, and myself. My presentation will be roughly divided in three main sections, 6 small parts. I'm going to talk to you a little bit about other related projects, so briefly an overview of other epigraphic databases, so that I can ease you in on how and why did we decide to start the Digital Epigraphy Toolbox, what is the main difference between our project and the other projects that are currently available online. The second section, I'm going to explain to you, without getting into too many technical details, how the Digital Epigraphy Toolbox works. I'm going to show you our interface, how you can use it. I have screenshots, we can use it all together online. I'm going to show you some of our experimental results. And the last section is going to be the second part of our project, not the Digital Epigraphy, the Digital Archaeology. Recently we have started digitizing in 3D other archaeological artifacts as well, statues, baths, vases, and so on. So this will be the last part of my presentation. We are all of us familiar with the epigraphic databases. With the epigraphic databases available online. I included some of these. Here all of you are familiar: the Electronic Archive of Greek and Latin Epigraphy, the Packard Humanities Project, the ECTIBA at the Berlin Brandenburg Academy, the Center for the Study of Ancient Documents, and several others. So what is the difference between all these? What do we hope to achieve with the Digital Epigraphy project? When someone wants to examine an inscription, it involves several different parts. You may want to examine the original inscription, the material, the ancient find spot, the modern find spot, the text itself, or all these things together. Most of these epigraphic databases give you access to either the text and or the other information about the actual stone, about the actual inscription. What we wanted, however, to focus on is how you can give people access to the raw material, and also how we can preserve and disseminate squeezes, the ECTIBA. Why is that so important? First of all, squeezes. When someone wants to examine a large, let's say a large area in Epidaurus, he visits the archaeological site, she spends several hours producing these squeezes, which then he houses in his office. And there are also large collections of squeezes around the world housed in several different institutions and museums. But the problem is that not all of us can get access. You cannot always travel to these places. There are cases where you want to teach a class that involve all these inscriptions, not to mention also the fact that there are squeezes of inscriptions that are now lost. The other part that got us interested, and we started the Digital Epigraphy Toolbox, is that, for example, the Packard Humanities Project gives us access to the text. So when we have a really badly weathered inscription, no one else gets the chance to have a second reading unless he can visit the place, he can find the actual inscription and try to read it, and try to make out all the weathered places. The Digital Epigraphy Toolbox aims to help people digitize in 3D their squeezes so that they can be preserved, they can be disseminated so that anyone can have access. They will not be lost, so that you can have access to squeezes again of inscriptions that are now lost, which means that they are our only source of information for those inscriptions, and also it will give everybody the opportunity to, let's say, reread these inscriptions. Now, a very logical question would be, so there is no one else who thought about that, and there are no other ways, why should someone use the digital epigraphy toolbox? Are there not any other ways to do this? You can, of course, take pictures of the squeezes. It's easy, it's simple, it's not expensive. The problem, however, is that you cannot, it depends on the light that you take, on the camera that you use. You cannot always, you can see that the result is not always better than if you actually had the squeeze in front of you. You can take several pictures of the inscriptions, like the HP Labs tried in 2001. You can put the inscription here on the platform, and then all these are different light sources. Of course, that would require to acquire the machine. And the second part is that if you take pictures of anything else other than a squeeze, which is a paper, it doesn't mean that you will be able to reproduce it in 3D. And I will explain later why. So you can have better lighting results, but it does not mean that you will be able to have the 3D representation of the inscription. This is an example of how the HP Lab method would work. Just to give you a quick hint, the problem is that not all the material properties of all the surfaces have been studied, but the material properties of the paper have been studied. So that is what gives us the opportunity to be able to create a 3D model of a squeeze, rather than of any type of inscription on any type of material. There is a so-called petroglyph digitization using laser scanners. It produces very good results, but again, it requires very expensive machinery, and we cannot always have access. Again, accurate results, and in some cases it must be carried to the site, which is not always feasible. And you can, of course, something which has become lately very popular, you can reconstruct a 3D scene from videos. But that would not work with either a squeeze, or in some cases with even with a stone inscription. It's only good for large objects. You cannot capture the detail that you need to capture when you want to read the text. Now, the digital epigraphy toolbox requires only the squeezes. It requires only a conventional office scanner. And of course, it doesn't need to be transferred to the site as long as you have the squeezes. So how do you do this? You take the squeeze and you scan it twice. It doesn't matter which side, you can do it like this and like this, as long as the two pictures are 90 degrees, have a difference of a 90-degree angle. That way the light comes once from that side, and when you turn the squeeze, it also comes from the other side, which means that you get as many details as possible from the squeeze. This is an example. I don't know if you can, if it's visible to everyone. In this case, the light comes from the top. In this case, it comes from the left. And these two images are the only pieces of information that we need and that our algorithm requires, so as to be able to reproduce the 3D anaglyph, the 3D model of the squeeze. As I told you before, since all the material properties of the paper have been studied, it's very easy. It's very easy only with these two pictures to reproduce the 3D model. The technique is known as shape from shading. And that's about it. You scan your squeeze twice, and you get a 3D model. There are several ways to visualize it, and that's a very important part of the digital epigraphy, of our interface and the way that you can utilize it. You can plot this 3D surface, so you can get something like that, which means that you can rotate it, you can zoom it and rotate it, you can relight it. Imagine we tried to bring people, scholars, researchers, students, as close as possible to the object, to the inscription. So what would you do if you had the inscription, or if you had the actual squeeze in your hands? If you couldn't read something, you would try to do this, and this, and this. So this is what we are trying to do. You can actually zoom as much as you want, you can rotate, you can relight as if you had the squeeze in your hands. Another very important attribute of the toolbox is that you can plot the height map. It's nothing else other than that all the dark intensities, like I explained, indicate deeper locations, which means that basically you can see that the letters look as if they were pretty much handwritten. In some cases, it really makes a difference, not only, or maybe in some cases not so much in the main body of the well-preserved squeeze, but it really makes a difference when you have weathered squeezes, weathered inscriptions around the edges. You can change the material properties. Again, it may not seem so important, but in some cases, if you change the color, the difference between the letters and the background really helps you. And imagine again, if you zoom this and if you rotate it and if you relight it, it can really make a difference in the recognition of letters. So this is it so far. As long as you have you got access to the inscription, or someone got access to the stone inscription, and you have the paper squeeze, you scan it twice, and then it's just a click of a button before you get the 3D and the height map. The second part, so this was our main goal, how we can easily digitize them and create the 3D models. The second part, which is equally important, it's not yet, it's fully developed, but it's not yet available to the public. It will be pretty soon. We can perform automatic post-processing analysis of the inscriptions. So the computer can automatically segment every letter or symbol of the inscription. If it may require some training at first. So for example, if you want to examine inscriptions from 2nd century CE, Asia Minor, and we don't have any of those in our algorithm, you may need to train the computer at first. You may need to do it manually for the first times, but then the computer will be able to do it automatically. And then again, automatically the computer can cluster all the similar letters into groups. So for example, here, all the alphas. Again, if it requires training at first, you may need to do it manually, but it then can be done automatically. Why is that important? Why would someone need to segment the letters and then cluster them into groups? Why go into so much trouble? What if you want to date an inscription? The program is not meant to substitute archaeologists or epigraphists or classicists in any way, but what if you have 500 inscriptions, 1,000 inscriptions, and you want to see if there is a pattern? If you want to study the lettering techniques, you can first have the computer do it for you, and then the trained eye can evaluate, validate, quantify the results. But you can do a lot more, a lot faster, and then draw your own conclusions. About the clustering of the letters, the computer then can perform what we call a registration of the letters. So it takes all, let's say, since I have the alphas here, it rotates all the alphas, it scales them so that they can, that they may overlap as much as possible one onto the other. And that way, you can have the average alpha of the group of inscriptions that you have entered into the computer. And you can also get the affinities between the alphas. How close, how similar is one alpha to the other alpha to the other alpha. And that is what I meant when I said that the computer can do it fast. It can tell you, okay, these look alike. And then you can decide if they do actually look alike, or what does it mean that they look alike. And here you can see, excuse me, this is the average alpha. This alpha looks 52% similar to that one. These two, they are grouped together, which means that the computer grouped them together. They look alike, but they are not as similar to the average alpha as is this one. I don't know if you can see it, but the average alpha has parts which are darker. The darker parts indicate that most alphas have the darker parts. Where it becomes grayer, it means that some alphas do not have, let's say, this part. And again, you can quantify the results. So again, it may require some training, but segmenting, grouping, registration, statistical analysis are all automatically done. When we first started, we initially applied our framework to 5 squeezes from Epidaurus, and I have here the bibliographical information if you are interested. They're actually published by Robert Fagman. He is part of the Digital Epigraphy and Archaeology group. And I'm going to show you 4 squeezes and the whole process. The two scanned images, the light from the again from 2 different angles, 90-degree angle. The second one, and you can see again the difference between having just a picture of the squeeze rather than having the 3D model. The third and the fourth, and now. Example of the 3D reconstruction, I know that they are not the same, this one was the first one, but you can see the difference between trying to read something from a photograph, a single 2D photograph, where you would only be able to zoom in, and having that, the 3D model and the height map. In some cases, it almost looks like it's handwritten. And then this is something that you can do with the 3D reconstruction. You can zoom in, you can examine the lettering technique. That is not something that the computer can tell you, but you can examine yourselves the affinity of the letters. You can tell when you zoom and relight if something is part of a letter or if it's just nothing, it's just a badly weathered squeeze or inscription. You can zoom in as much as you want. I'm going to show you on the interface in a little bit. Again, the letter segmentation, automatically done. The only part that you would have to clean up is this part that the computer thought that it might have been a letter, that you would have to just clean it up yourself. And I only chose here 4 letters, the alphas, the epsilon, sigmas, and the ypsilons of those 5 squeezes that I showed you at first. So these are the alphas, and these are the groups of the other letters. And now, what he can do with these affinities and the registration, he can automatically get the so-called dendrogram. So all the affinities, the similarities, and the differences between the letters, he can get them like that. So what does that tell us? First of all, as I explained before, when you get the average epsilon here, the dark intensity indicates that all or the majority of the epsilons have these parts. Here, it will be, the PowerPoint will be available online, it's clear there. This is grayer, which means that there are some epsilons that lack this part. Again, that may not mean, that may mean nothing. It may be a matter of how the squeeze was done or anything like that. But you can decide what it means and if it means anything. And then the grouping of the epsilons. If you notice, the computer decided that all these 5 inscriptions look a lot alike. They're lettering techniques. So that's why all the epsilons are grouped one with the other, and they show close affinities. Which is actually, we knew that those 5 squeezes came from the temple of Asclepios in Epidaurus. That's why we started with something that we knew. And the computer actually found that they do look alike. When the epsilons are joined together, it means that, for example, these two, they look almost alike. And the third one looks very much alike with these two. What it gets interesting is when you get to these 2 epsilons, the computer has joined them with the rest of the group, even though it shows that they don't look so much alike as the others, and they are grouped together apart from the others. Why? They are the only 2 epsilons where the middle line does not touch the main body of the letter. So they don't look so different so as for the computer to group them, to cluster them somewhere else, on the one hand. On the other hand, they look alike, so they are grouped together. And the third part is that this is why the average epsilon has a middle gray area, because these 2 lack this middle part. And you can see the same with the alphas. Like I say, we don't have any significant subgroups. Again, the computer indicates that the lettering technique, the letters look very much alike. The same with the sigma. Again, darker here, a gray area here and here. And the same with the epsilon. And this is the Digital Epigraphy Toolbox interface. This is the 3D model, just a screenshot for now. This is the 3D model. You can translate it, you can move it, you can rotate it, and you can relight it. You can also browse, search by keyword, or if you want to add your own squeezes, you can click here, input. You will need to get a password and a username from us so that we can keep track of who is doing what, and so that no one can alter any entries. You can add the 3D object. For example, if you have a photograph of the actual inscription or of the monument where that inscription was found, you can upload it here. You can add any images, even 2D images that you may have either of the inscription or of the squeeze, and any other information that you may have, again, material, IG number, CIL, find spot, anything. This button is the one that does all the work. 3D from, this is basically 3D from 2D scans. When you click there, you have your basic selection, the option. You click on your computer, you find your 2 images, your 2 scanned images, and they are automatically uploaded and digitized in 3D. And the zoom that I forgot to show you. How you can search and how you can input information. Let's do the search. You can do it by ID number, for example, IG or CIL number, by the location, bibliography. We have in all these areas, we have drop boxes, and you can search by the, again, like I said, the material property, the ancient find spot, the modern country, basically anything, and you can do the same. You can add any entry that is available to you about your inscription. With the input button, you get the same selections here and the same drop boxes. Now, what if you, for example, you're not sure what you are looking for, or you don't have all the necessary information so as to get the one inscription that interests you? Let's say that you type just Epidaurus because you simply want to browse through our database. You will get all the possible results, all the results that have the word Epidaurus in their data. And some basic information, not all the information that we have about the inscription. Once you decide which one is that interests you, then you can click, and you will get all the information about the particular inscription, and of course image the entire 3D model. About the information, and this is how the input, the edit graphical information page looks like. Inscription type, province, modern country. The information box here, you can get information about this inscription, any information about that inscription that exists online, even if it is on another website. You will get, for example, if you have that inscription, if you have the text in Packard Humanities, then you will get the URL and it will show you the text. And of course, all the other information that were added to the system. This is a demo, you can see. You can see the relighting, it really makes a difference, and you can. The advantages, I think I hope that I made them clear. You can preserve, disseminate, study, restudy inscription. You can use them for your own research. You can disseminate them. The drawbacks is that some details of the inscription, such as depth, cannot be captured. And then there are some issues with very large squeezes. What we plan to do in the near future is that we are going to embed a separate program in the Digital Epigraphy Toolbox that will be able to stitch the inscriptions, the large inscriptions, the pieces together. So far we have been, when we are contacted about how someone can digitize his hair squeezes, but they are very large, we usually do it manually. But it will be an option that will soon be added. And that was the first part, the Digital Epigraphy Toolbox. The second part of our project includes the Digital Archaeology. Again, we are not the first. There are several archaeological databases, database of archaeological artifacts. These are the maybe most visited ones, the most well-known ones. The one housed in the Louvre Museum, British Museum, Claros, the Google Art Project. They all have 2D images, 3D images. You can zoom in some cases. So what do we hope to add to this? With the use of 3D scanner, we hope to digitize in 3D archaeological artifacts so that we can have them on our database, and you can study them, you can zoom in, you can relight, you can perform the same things that you can do with inscriptions, but with an archaeological artifact. Our ultimate goal is that we will have the option to, let's say, upload 4 different busts or the imperial bust from Capitoline Museum, and you can study the construction, the form of the busts. You can find, you can study the way they were made. This is the first one that we tried. It's the so-called Sphageion, courtesy of the Tampa Museum of Art in Florida. You can see that it's a very good 3D model. We scanned it using a handheld Artex scanner. And you will see here. This is the cloud of the cloud of 3D points that then give you the 3D anaglyph of the artifact. We also digitized the seal of the University of Leipzig. This, you don't need to have the seal, and you can also do it for coins. You don't need to have a scanner, you can, a handheld 3D scanner, I mean. You can just do it the same way that you would do with your squeezes. Just a regular office scanner, as long as you can keep the same angle if you make a mark or something on the scanner or piece of paper. And you can, this part I have in detail, you can see how much detail you can get with the 3D model. This database of including the inscriptions and the archaeological artifacts, we called it the Digital Epigraphy and Archaeology Virtual Museum, and actually this is the first time that we presented to the public today. You can, it has all the properties that the Digital Epigraphy Toolbox has, but it's not necessarily meant for researchers or scholars or people who want to add their squeezes on our system. You may have a student who wants to just browse, look because he's taking a classical archaeology course and nothing more than that. You may have your own web page. If you want to embed one of these artifacts or one of our inscriptions, you can simply copy the URL and embed it as is on your site, on your website. Again, when you do search, you get all the different results. You can click on the one that interests you. You get it the full size and all the information that we have available. You can rotate it. We can get here. Like I said, you can translate it if you want a particular part. You can rotate it. You can relight it. You can have either the 3D or the 2D, and you can also have it full size. And again, you can do it with any of your results or any of the inscriptions that we have online. Our future directions include the virtual representation of theatrical constructions in ancient Greece. We have at the University of Florida and the Digital Worlds Institute, they have created an algorithm where you can, if you have a depth camera, you can create your own avatar, which you can then place, let's say, the example that I have here is the Theatre of Epidaurus. You can place yourself here. Why would you do that? You can measure, just for fun, but you can also see how you, if you would need in some cases, in some place, if you could need 3 or 4 actors, if you would have a mute actor, if someone would have the time to go backstage and change. Every step that you are taking in real life is a step that you take in the theater. And all the 3D model here is constructed based on all the archaeological information and the measurements of the actual sites. We can examine theaters how, let's say, the orchestra in the theater of Thorikos, which is not circular, how it would work for comedic choruses, and so on and so forth. So this is our part of the future directions of the digital epigraphy and archaeology project. It can just be one of you, but you can play just one of you. You can play the chorus. It will make a difference. You can see how, if the theater would be large enough to have, for example, the 24 member choruses that we believe that comic choruses consisted of, or anything like that. You can, what if you wanted to be, let's say, to be on stage, or what if you wanted to be a member of the audience, since you cannot walk forever so that you can get up on top. If you click somewhere, then you are sitting over there. So every step you are taking it from over there. And that was it. Thank you very much.
Thank you very much for an extremely interesting talk. I've got a couple of questions for you myself, and I shall open up the questions to the floor. I was wondering about the workflow. So let's say I have a collection of squeezes and I want to make some or all of them available using your tools. Mm-hmm. Where do I start? Where do I start? That's really the question.
We have the, I couldn't show you with Java, but you can contact us. We will give you, like I said, we will give you a username and a password. All these, every time that you log into the system, so as to check out something, to add any information or to delete any information, your details are recorded. So that way your data are all protected.
So essentially,
and then after that you just upload them and...
Okay, so there's a record of what I've done?
Yes.
Okay. Is there an editorial board which checks the information that I'm providing? And if so, how does that work? Are there several people on the board who look at the details that people submit and then say, actually we can't accept this, it's not good enough quality, or whatever, and then send it back for... How does that work?
So far we have been working with data that we ourselves can validate. So we have digitized the collection of squeezes from Epidaurus that Dr. Wagman has, and he quantifies and validates the results. We have digitized the collection of squeezes from NEMEA, but the University of California at Berkeley have given us their collection and they are responsible for them, and we have not yet published anything. So once the workload becomes a lot, once we have, let's say, a student and a budding archaeologist who wants to, then we will start filtering, and we will have a group of archaeologists, inscriptionists filtering through the data. But up to now, again, we only work with people who want to digitize and preserve their squeezes, and they are responsible for the information that they enter.
Okay, I also wanted to ask about the end user, which might of course be one of us. What would I take away from the database? What do I download, and how am I allowed to use it? If I use some material from the database, what am I allowed to do with it? What's the sort of accessibility issue?
First of all, you cannot alter any data without us knowing. Second, you can upload and digitize your squeezes and decide that you don't want to have them online. So that is why we don't have yet collections of quizzes online, except for ours that Dr. Wagman again has given us permission to use. So you can decide how public they want to be, if you just want to preserve them for you and for your classes, for your colleagues, and if you don't want the whole world to see them. So you can actually, it's not like you upload them and you don't have any control over your data anymore. You decide how public you want them to be. You decide how you want to use them. As far as the downloading, the 3D images, they are very small. They are not like a gigabyte or terabyte or anything. It's just regular pictures.
But if I wanted to download something from the site, as long as it had been agreed by the person who'd uploaded it, I could download a number of different squeezes and use them for my own purposes. Yes. Is that okay? Thank you. That's